All right. So we're going to talk about rewriting equations and formulas today. And so we're going to learn to rewrite literal equations. We're going to learn what literal equations are. We're going to rewrite and use formulas for area and also for other common formulas. So when so far in this class, we've only looked at equations that have one variable in them. And then when there's one variable in an equation, it's easy to know which variable to solve for because it's the only one there. So now we're going to look at what do we do when equations have more than one variable in them. So equations with more than one variable are called literal equations. You can kind of think of it as like literal, literature, letters. I don't know, but an equation that seems to have too many letters, we call it literal equation. To rewrite a literal equation, you just solve for one of the variables. So you get one variable by itself, everything else is going to be on the other side of the equal sign. And you basically are going to go through and you're going to be either told which variable to solve for, or you're going to have to figure out which variable to solve for. And once you do that, you treat all the other variables like they're numbers. And then you're just going to use inverse operations and the same process that we've been using to solve. So here's our first literal equation to solve. You can see this is a literal equation because it has x and y in it. So they want us to solve for y in this situation. So 3y plus 4x equals 9. If we want to solve for y, then we need to just look at what operations are happening to y and do inverse operations. So y is being multiplied by 3, and then they're adding 4x. So we just need to, we're going to follow the same process as before. Y is the variable we want to get by itself. Everything else we treat as a number. And we just use inverse operations to solve. So do we want to get rid of addition first or multiplication first? Addition first, right? So we're adding 4x. The inverse of adding 4x would be subtracting 4x. And we got to do that once on each side of the equal sign. And now we have to be really careful because we did inverse operations to both sides of the equal sign to get this plus 4x away from our 3y. So now we have 3y equals, but on the right side, 9 minus 4x, it's a very common mistake for students when you're doing inverse operations to both sides to combine things that are not like terms. That's a common mistake. So you have to look, when you're doing minus 4x to the right side over here, you can only combine that with something if it's a like term. Since there's no x on this side, we can't combine these two values, the 9 minus 4x. So it just stays 9 minus 4x. Right? Because at this point, we actually don't really know what x is. So 9 minus 4x is just 9 minus 4x. So you can only combine things if they're like terms, right? So now, remember, we still want to just get the y by itself. And that might be another difficulty of doing literal equations. You might halfway through start solving for a different variable, forget you were solving for y, and now get x by itself. So you got to double check, make sure you're doing the working on the right goal. So we want to get y by itself. Y is only multiplied by 3 right now. So all we need to do is divide both sides by 3. You got to be careful. Divide both sides by 3 means both sides of the equation. So the left side, we divide that by 3, and the right side, we divide the whole side by 3. So 3 divided by 3 is 1. That's why those are inverse operations, and we get y equals 9 minus 4x all over 3. And that's fine. You can just leave it like that. Because we have solved for y in terms of the other variables. Yes, I do. Okay, so example 2, we get this literal equation y equals 3x plus 5xz, and we need to solve for x. Okay, so we need to figure out how to get the x by itself. We need at the end of this problem, our answer needs to say x equals, and then some stuff that's going to have z and y and probably a 3 and a 5 somewhere. But right now, x is in 2 spots. Right? We've got x here and we've got x here. So how can we get x to be in one place instead of 2 places? We can do like the reverse of the distributive property, and we can factor that x out, right? I'll show you what I mean by that. Y equals, so if you have you remember the distributive property, where if you have, like, say x times a plus b, you would multiply the x through, you'd get x times a plus x times b. Well, you can go in the reverse order too. If you see that there's a common factor in both terms, you can factor that factor out. So we're going to do that with this x. We're going to bring the x outside and then say, what would be left? What would we need to multiply by here to get 3x? Just 3. What would we need to multiply the x by over here to get 5xz? And it's just a 5z. So now we have our x just in one place, right? X times this parentheses quantity 3 plus 5z. So how can we get x by itself? Well, right now x is being multiplied by this big chunk of stuff. That's one operation that's happening to x, right? X is being multiplied by 3 plus 5z. So that means that we can divide both sides by 3 plus 5z. Because x times 3 plus 5z, then divided by 3 plus 5z. Whatever z, like 3 plus 5z, you got to think of that. That's just a number, right? Somebody knows what z is. We're gonna say somebody knows what z is. So 3 plus 5 of those is just a number. So if we divide both sides by that same number, then these will cancel out, and we get y over 3 plus 5z equals x. So you could write it either way. E plus 5z. You could even write y over 5z plus 3. It's the same thing. So if you see the variable you're trying to solve for in more than one term, then you need to get those terms together and factor it out. Okay. So rewriting and using formulas for area. So sometimes you'll be like, all right, this is the formula for the area of a cube, or the area of or surface area of a cube, or the area of a rectangle. And then you'll need to do some, what you can do is you can solve the literal equation for what you want and then just plug the numbers in at the end. This comes in handy in science classes where you're going to be using the same formula over and over again. You can take the formula and rewrite it, solved for different variables, so that it'll make it less work for you in the long run. So let's say that you have like a class where or you have to keep using this same surface area formula. And there's a bunch of problems where you need to solve for the length. It might be easier to just rewrite this equation solved for length and then just plug everything into that. So we'll do that. We'll take this formula, S equals 2LW plus 2LH plus 2WH, and we're going to solve for L. So we got L showing up in two different spots. So we're going to have to factor the L out of there. That almost sounded like I was saying something bad. Man, we got to factor the L out of here. Okay, so I'm going to factor the L out of here. And since only the first two terms have L's, I'm only factoring out of those first two terms. So there's still this plus 2WH at the end. So now when I take the L out of the first term, I'll have 2W. And if I take the L out of the second term, I just have 2H. So I'm going to highlight the L again so we remember that's our target. And so now we need to look at what operations are happening to L that we can undo with inverse operations. So one of the operations is it's being multiplied by this chunk 2W plus 2H. So multiplication is one. And then we've got adding 2WH to it. So addition is another one. We'll start by getting rid of the addition. So we got plus 2WH. So I'm going to subtract 2WH from once from each side of the equal sign, right? Once from the right side, once from the left side. It cancels out on the right side. And S minus 2WH, those aren't like terms. Like terms have to have the exact same variables. So we can't combine those. We just have to write them out. So S minus 2WH equals L times 2W plus 2H. So now our L only has multiplication happening to it, right? It's being multiplied by a big chunk of stuff, but the only thing that's happening to L is multiplication. So the inverse of multiplication is division. So we're going to divide both sides by whatever L is being multiplied by, and that is the 2W plus 2H. So on the right side, these will divide each other out, and we get L equals surface area minus 2 times width times height divided by 2 width plus 2 height. Okay. Okay. Ándale pues. Okay. Let's go on to the next one. So here we're going to use a formula for area. You own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet. I'm going to highlight that because that's important sounding. 500 feet deep. Area is 100,000 square feet. To pay for a new water system, you're assessed $5.50 $5.50 per foot of lot frontage. So the frontage you can see from the picture is the width. So depending on how many feet wide our property is here, that's the number that they're charging us per foot on. So we have to figure out what that W is. So part A is going to be find the frontage of your lot. Okay, well, we have the area and we have the depth. So for in this situation, we got like this is like the length, and that would be the W would be the width, and the area of the rectangle is length times width, right? So if we wanted to find the width, we could take this and divide both sides by the length, because that would get the width by itself. And that gives us the formula W equals A over L. Width equals area divided by length. So then we just need to substitute in what we know. We know that the area is 100,000 square feet. The length is 500 feet. So 100,000 feet divided by, or 100,000 square feet divided by 500 feet is 200. And then square feet divided by feet is feet. So the width is 200 feet. So for part A, we got the width was 200 feet. For part B, how much are we going to be assessed for the new water system? They're charging us $5.50 per foot of frontage. Our frontage width is 200 feet. So 200 feet times $5.50 per foot. The feet are going to cancel out, and we're going to be left with dollars. 200 times 5.5 is 1,100 dollarinos. Okay. So I remember there's 8 examples on this one, so plugging right along. The next slide is going to be some formulas that you need to write down. So I'll go ahead and go to the next slide and let you write down these formulas. So these are some common formulas. They give you the explanation too, so I'll highlight the formula part. So this is the formula that relates Celsius to Fahrenheit. This is the formula for interest. I is the interest, P is the principal, R is the annual interest rate in this form of a decimal, and T is the time in years, and then distance equals rate times time. So those are some formulas that are pretty commonly used. So we're going to play with those in the next few examples. So the next, what we're going to do for on the next slide, so example 5 is basically going to be, we're just going to take the first formula here, and we're going to solve for F. Doesn't that sound exciting? Totally be able to find out Fahrenheit, even if they give us Celsius. It's going to be great. Okay. So let's take a look at this temperature equation. So we're going to solve the temperature formula for F. Okay. So looking at the formula here, let's try to figure out what we're going to do. F is what we want to get by itself. What's happening to F right now? We've got subtraction, minus 32, and we've got multiplication by 5/9. Now, generally, we like to get rid of addition and subtraction before we get rid of multiplication and division, right? The problem with that in this situation is that the subtraction is locked inside these parentheses. And that means that what's really happening here is we're not really doing F minus 32. We're doing 5/9 of F minus 5/9 of 32. So if we tried to add 32 to both sides of the equation right now, that wouldn't actually help us. So what we have to do first is we have to get rid of the 5/9 because the 5/9 is affecting that subtraction in there. So the way we can do that is remember, anytime you have a fraction multiplier, you can get rid of that by multiplying by the reciprocal. So the reciprocal of 5/9 is 9/5. So we're going to multiply both sides by 9/5. What ends up happening on the right side is you'll get 45/45, which is 1. And then 1 times F minus 32 is just F minus 32. So we get F minus 32 on this side, and on this side we get 9/5 times C. And now we can get the F by itself just by undoing the subtraction. So the opposite of subtracting 32 would be adding 32. So then we just get F on the right side, and on the left side, 9/5 C plus 32. 32 doesn't have a variable on it, so these aren't like terms, so we can't combine them, so we just have to write them both. 9/5 C plus 32. And that's our formula for Fahrenheit. Fahrenheit, in terms of Celsius, is 9/5 times the Celsius plus 32. Okay, so next, we're going to actually use that formula for example 6. Which has greater surface temperature, Mercury or Venus? Well, they give us this information over here. Mercury, the temperature is 427 degrees Celsius. And Venus the temperature is 864 degrees Fahrenheit. And we just figured out that F is equal to 9/5 C plus 32. So right now we have one temperature in Celsius and one temperature in Fahrenheit. So in order to compare them, we need to get them into the same units. So I'm going to take the 427 degrees Celsius that mercury is, and I'm going to plug that in for C and find out what that is in Fahrenheit. So in Celsius, 427. Okay, so now I'm going to need Mr. Calculator. And when you're doing a fraction times an integer, you can think of the integer as being 427 over 1, and then you multiply the tops and then multiply the bottoms. And a shortcutty way is to take the 427 and multiply by 9 and then divide by 5. So I'm going to grab a calculator. Excuse me. I'm going to do 427 times 9 divided by 5, and I get 768.6. So 768.6. 768.6 plus 32. So plus 32 would give us 800.6. Okay, so mercury is 800.6 degrees Fahrenheit. Which one has a greater surface temperature? Venus. Because 864 degrees Fahrenheit is greater than 800.6 degrees Fahrenheit. Okay, two more. The next one, we're going to use the formula for interest. The next problem is going to be so interesting. No. I need to get a drummer in here to do after all my cheesy jokes. Okay, so example 7. You deposit, dang, you're rich. You deposit $5,000 in an account that earns simple interest. After 6 months, the account earns $162.50 in interest. What is the annual interest rate? So what we're going to be solving for, what is the annual interest rate? We're going to be solving for R in this equation, I equals PRT. So if I wanted to solve for R, what I'm going to do right now is I'm just going to solve this equation for R. R right now is being multiplied by P and T. So if I divide both sides by P and T, then the P's and T's will cancel, and I'll get R equals I divided by PT. Okie dokie. Does anybody remember anything special about T, though? T is time, right? Time measured in what? In years. So what do you, if T, what T value corresponds to 6 months? 1/2, right? 6 months is 1/2 of a year. We can write 0.5 because that's the same value. So what we're going to do is we're going to plug in for I and P and T. So the interest was 162.50. The principal was 5,000. That's how much we deposited. And the time was 1/2 of a year, so 0.5. And then we can just get our trusty handy dandy calculator. Oh, you probably can't even see the calculator, can you? Nope. So we're going to do 162.5. Actually, you know what we'll do just to make it a little easier, because not all calculators do what's the order of operations. So we're going to multiply the 5,000 times 0.5 down here first. And that should be 2,500. So then we're going to do 162.50 divided by 2,500. 162.5 divided by 2,500 is 0.065. So that is the rate expressed as a decimal. When we're actually doing the math problem, we need the rate expressed as a decimal. But when you're saying what the interest rate is, they usually say it as a percent. So if our decimal rate is 0.065, what's that as a percent? You just move the decimal place 2 to the right, and it's 6.5% interest. One last one. We're almost done. Annual interest rate. One last one. Almost done. Somebody's playing with skateboards. Okay, let's do this. Big old word problem. Truck driver averages 60 miles per hour while delivering freight to a customer. On the return trip, he averages, or he or she averages 50 miles per hour due to construction. The total driving time, 6.6 hours. How long does each trip take? Okay, let's figure out what we know and what we need to know. We know the rate. This is the rate on the way there. This is the rate on the way back. We have a time, total time. And there was a certain distance that they went, right? And it was the same in both directions. So we're gonna be using the formula D equals RT. And how long does each trip take? We need to solve for, well, how long does each trip take is probably something that we're going to have to answer at the end of this, because we're going to need to figure out the distance. We have 2 rates and a time, so we're going to have to figure out a distance, right? So let's see what we can do. Okay, so if we add up the 2 different times, so like if we say like the time it took to go there, time there, plus the time it took to come back, that would equal 6.5% 6.6 hours. So what we can do then is we can use the d equals r times t equation to get time by itself. So we're going to divide both sides by r, and we get t equals d divided by r, right? Time equals distance divided by rate. So then what we can do is the time there was the distance divided by the rate going there. The time it takes to come back is the distance divided by the rate coming back. And we know what the rate going there and the rate coming back were. They gave it to us in the problem. So this is d over, the rate there was 60 miles per hour. The rate on the way back was 50 miles an hour. Now the trick on this one is, how are we going to get the d in one place so we can solve for the distance? And in order to add fractions, you have to have a common denominator. So what are they both going to go into? 300. Is 300 the smallest that they both go into? Well, I think they both do go into 300. So let's see, what would we need to multiply 60 by to get 300? 5 times 6 is 30. So then we need to do multiply this, the first fraction, by 50 over 50, multiply the second fraction by 60 over 60, and that'll give us two fractions with 300 as the denominator. So we can multiply this by 50 over 50 because we're just multiplying it by 1, right? And it doesn't change the value. So then we get 50d over 300 plus 60d over 300 equals 6.6. Gonna have to move this equation up here. So now that we have the same denominator, 300, we can add the numerators. So yes, no, wait, yes. 5 times 6 is 30. Yeah, I need another 0, huh? Good catch. Say what now? That's true. That's true. Yeah, so we could right now, we could reduce those fractions before we even add them, right? It could be 5 over 300 plus 6 over 300. So either way, yeah, so that would be one kind of little shortcut to do. So what I'm going to do right now is I'm just going to add them together. 50 plus 60 is 110. So 110d divided by 3,000 equals 6.6. And then what we could do, multiply both sides by 3,000 and then divide both sides by 110. Or you could do it in one step by multiplying both sides by 3,000 over 100. But that doesn't really make it any faster, so I'm just going to do one step at a time. So first I am going to multiply both sides by 3,000. Yeah, am I writing? So what that's going to do is cancel these. So we have 110d equals a calculator. 6.6 times 3,000 19,800. And then we're going to divide both sides by 110. And we get D equals 180. So now that tells us the distance that he drove. The question they're asking us, how long does each trip take? So the time for each trip would be distance divided by the rate, right? So on the way there, it's 180. So remember right here, like we figured out that time is distance divided by rate. So the way there, it's 180 divided by the rate on the way there was 60. So that is going to be 3 hours, 180 divided by 60. And on the way back, the distance was 180, but the rate was 50 miles an hour. So 180 divided by 50 be 3.6 hours. So it took 3 hours to go there, 3.6 hours to come back. So the main idea of the lesson is that you can take a formula and solve it for one of the variables and then just plug things in at the end.